Hello everyone, welcome back to my YouTube channel. So today we are going to solve day 28 problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with the today's problem. Problem number 1351. Count negative numbers in a sorted matrix. So this problem is marked easy by LeetCode. It is also very important for interview rounds. Why I'm saying so? So let's first read the problem statement. So you are given a m into n matrix grid which is sorted in non-increasing order. Important line. Which is sorted in non-increasing order, both row wise and column wise. Right? We have to return the number of negative numbers in the grid. Right? Here, if you see the constant size, it's very small. M is grid dot length, n is grid I dot length, and m and n values from 1 to 100 only, right? Number of rows, number of columns, right? And grid of ij value is also from minus 100 to 100. But this is the part which your interviewer will definitely ask you, right? If he gives you this type of problem, right? So this is the important part. Can you solve this in n plus m time complexity solution? Can you provide that, right? So I'm going to solve this problem using three approaches, right? Approach 1 is going to be very simple brute force, right? In which I will just iterate over all the elements in my grid matrix, right? And whenever the element is less than 0, I will just increment the count. So this is going to be my approach 1, right? So for approach 1, let's write the code, right? Then I will move to the approach 2, and then after that I will move to the approach 3. So I will not waste much time here. Very easy problem, nothing complex here. So first, number of rows is nothing but grid dot length. So it is going to give you the number of rows, and number of columns is nothing but, so just pick first row and just calculate the length of the first row. So it is going to give you the number of columns, right? And here just create one variable int count and just set it to 0. And then after that you have to run two loops. You have to iterate over all the elements in your matrix, right? In this grid. So I is less than m I plus plus, so we are just running the nested loops, right? So here int j is starting from 0 and j is less than n, and here j plus plus, and here I will just simply check if grid of I and j element, right? If this element is less than 0, in this case just increment the count plus plus, right? And here your for loop ends, so here you have to simply return the count. So this is going to be your approach 1. Very simple, very easy. But reason is the time complexity is m into n, which we don't want, right? Solution will be accepted, right? Because the constant size is very small, right? So solution will be accepted, right? So see, solution accepted, right? But now we have to optimize it further, right? So approach 1 is done. Approach 1 is done and dusted, but time complexity is of m into n, since we are iterating over all the elements. Now in my approach 2, since I know that all these rows and columns are sorted in non-increasing order, right? So this is the case. So I can do one thing. Sorting is there in my rows, right? So if you just pick this row first, 4, 3, 2, -1, right? So in this, I just need to find out the first element which is negative, right? So here this is the first element which is negative. Same way in this, if I just select this row, right? So 1, 1, -1 and -2. So this is the first element which is negative, right? So here, what is the total length of this column? The column's length. Column length is 4, and the first index 0, 1, 2, 3. The first index at which I have a negative value, so that is nothing but 4 minus this 2. So this is going to 2. So 2 is nothing but these two elements, right? 4, and I subtract the index at which first negative value is there. So now in this case I am iterating over all the rows, right? I am iterating over all the rows, but in the column side, right, I am applying the binary search. So the time complexity will be reduced to m into log n this time. Okay, right? And binary search, you already know how it works, right? So let's take this example 4 3 2 minus 1, right? 4 3 2 and minus 1. Okay, so many things will be clear as part of this problem. Okay, so that is why good problem, right? So here if you pick this, right, so in this what you need to do always in case of binary search, right? So you have to take one L and one R. So just take your L value is 0 and R value as the last the total number of values is 4, and this is the last index, right? So you can say n minus 1, that is nothing but 3, right? N is total number of elements in a column, right, in a row, minus 1, so that's the number of n minus 1. You will get this 3 index of this 0 1 2 3, right? So now you need to calculate the mid. So I already told you that you can calculate the mid like this, right? But sometimes if L and R values are very large, which are not in this case, so you can apply this simple thing as well. But what I told you what to use always, because this L plus R, if both are very max value, you will get integer overflow type error if both L and R are very large and you are doing the addition. So it's always better to use something like this, L plus R minus L divided by 2. So this is same thing, this is same thing. Okay, this is same thing, L plus R minus L by 2, because this is same thing. 2 goes here, so it becomes 2L plus R minus L and overall divided by 2. Then this is 2L minus L plus R. So both are same thing, but use this, right? So that we don't get the overflow error, right? So this is just something extra, right? All right, so this is good, right? So now you have to calculate the mid. So here 0 and here 3, so 0 plus 3 divided by 2, so you are going to get 0 plus 1, that is 1. So 1 as the mid for very first time, mid is 1. Okay, let's use some other pen, right? L is equal to 0, R is equal to 3 and mid is equal to 1. So tell me, this is your mid, this is your L, this is your R. Okay, so now tell me, I have to run the loop while my L is less than equal to R. Okay, this is my while loop, so this I have to continuously run. Okay, so now in this case this is the mid. So now tell me the mid element, right, this element, tell me it is less than 0 or not. So it is not less than 0, right? So what I have to do in this case, update your L as this value, mid plus 1. Update your L as mid plus 1, right? So if grid of I and mid value, right, mid value I'm checking, if it is less than 0, right, then R is going to be mid minus 1, right? Otherwise L is going to be mid plus 1, right? So it is true now, right? You are searching for the negative value, right? You are searching for the negative value, so here your mid is there. So if this is not negative, definitely the negative value exists here in this side. So that is why your next time L is going to be the mid plus 1. So in this range you have to check, right? Because until here there is no negative value, so L is going to mid plus 1. So in this range you have to check now, right? So your L is going to become what in the next case? So L is going to be 2 next case, right? So L is 2 now, R is this 3, mid is going to be what? Mid is going to be uh, again apply the formula, same formula. So that is nothing but you will get 2 plus 3 5 divided by 2 is 2, right? Mid you are going to get a 2. Okay, so mid is just nothing but it is 2 now. Okay, so now again, right? So now this is mid, right? Again this value is not less than 0, so definitely your L is going to move forward, right? So now let's use some other pen. Your L is here, your R is here, and mid is also going to be this value. But this time your this value is negative. So in this case your R is going to move backward. Since your R is moving backward, right, so definitely this statement will not true, right? So you have to stop. And in the last time your L is here, right? So this is nothing but the index of the first value which is negative, right? Your L is always moving forward until we find the negative value, right? So now this is what we need to do, right? So here L plus R mid is going to get this only. So here if you see this is negative, your R is moving backward, but the last time L is here, right? So that's what we need to do, right? So let's write the code, very simple, nothing complex here, also very simple. problem. Okay, and here this count you have to find, and here you have to run one I loop. Now instead of this, right, we are checking all the elements. Instead of this, now I have to apply some shortcut here using the binary search, right? So here I am taking int l, right, int l, and I'm setting it to 0, and I'm taking one r, I'm setting it to n minus 1, right? And then inside this I'm just going to run one while loop, and in the while loop I'm just going to check what l is less than equal to r, and here inside this I will just first calculate the mid value. Mid value is nothing but you can use this l plus r minus l, and here divided by 2, right? And here you have to just use the logic if grid of I and mid value, right? If grid I and mid value, if this is less than 0, right, if this value is less than 0, in that case what you need to do, your r is going to be updated with mid minus 1, and in the else part your l is going to be operated with mid plus 1, right? This is what you are doing every time, right? And once this is done, right, once this while loop is done, now your l is the first negative index, right? So you have to update the value of count as count plus, and here n minus l, total number of columns in a row minus l, right? So that's it, and in the end you have to return the count. So we are iterating over all the rows, but we are not iterating over all the columns. We are not checking that. Okay, so that is why now our little bit this m into n time complexity, it is going to be reduced to m into log n this time. Okay, so that's it. So this is the code for this binary search, right? And here if you see the time complexity, m into log n now. Okay, this is done, right? Now the best solution for this approach, this problem, okay, that is nothing but your approach number 3, that is going to be O of n plus m solution. Okay, so now here you know that in rows values are decreasing, in columns in all the rows values are decreasing, right? Values are decreasing, right? Values are decreasing, right? Same way here values are decreasing in the columns as well. 3 2 1 minus 1 2 1 minus 1 minus 2 minus 1 again minus 1, right? It's minus 1 minus 1, both are same, but it's not increasing, right? Here minus 2 decreasing, minus 2 decreasing, right? So in rows and in columns the values are continuously decreasing, right? It is going to remain same or decreasing, remain same or decreasing, but it's not increasing, right? So now from here one thing comes to my mind, right? So if I am here, right, and if I just check this value, so tell me, this is the last value, right? Okay, for this particular row. Now tell me, if this value is minus 1, definitely all these values will be smaller than the minus 1 itself, right? If this is value is negative, all the other values below it are negative only, right? Okay, clear this thing. So if this is negative, right, so I can simply do one thing now. Total number of rows I have m, and at which row I find this negative value. So this negative value is at this 0th row, m minus row. So m is nothing but total number of this 4 minus 0, so 4. So 4 values here, right? 4 values, these 4 values are negative, right? Okay, now if this is the case, if this is the case, right, if this value is negative, then in that case we have to count all these 1 2 3 4. I count all this, and then I make a jump to this one directly. Okay, I make a jump to this one directly. So initially I am at this particular column, now my column is decremented, I move to this, okay, and I count this value. Now here this value is positive, this value is positive, this value is positive, right? So definitely previously all the values are positive only. If this value is positive, definitely previous values are positive only, right? So I don't need to check this row for the remaining rest of elements, right? And for this column, let's make a jump to this particular position now. I'm incrementing the row plus plus, right? Row plus plus. I'm moving to this row now. Okay, this value is also positive, right? This value is positive, so that means all these values are positive only, right? I don't need to check the remaining stuff here, right? I'm going to make a jump to here, right? Now I make a jump, I find out that this value is negative. So if this value is negative, right, so definitely the below values are also negative. So here again I will apply the formula m minus rho. So m is 4 and I'm at this 4 minus 2, so I will get 2, right? But now I here this and this I counted, but if this is negative, then maybe this one is also negative. Now I'm moving to the this position, right? So if I find negative, I am moving to this. If I don't find a negative, I'm moving coming down. Now here it is positive, definitely below all the values are positive. Let's check down, right? So this is negative, so here I'm going to count one more value here, and then I'm making jump here. Here there is one more value, right? So 1 2 3 4 5 6 7 8. So this is type of a staircase type problem, right? So staircase only, right? See here, minus 1 minus 1 minus 1, then I move here, then I move here. Okay, like this staircase is there, right? Minus 1, let me use some other pen. Okay, this, see this, minus 1, then minus 1. See, this is type of a staircase that I'm forming, right? Okay, so that's it, right? Now you will see the solution, very simple. Okay, so here m and we are finding, and here just do one thing, copy this, control C, and just paste it here. Here let's say this is nothing but your row, okay, and this is your column. So this is how I'm starting here, right? And now what I need to do here, I am returning the count here, and this is where this loop ends, so let me remove it. Okay, now I will write the code inside this. Very simple, it's going to be very simple. Okay, so here what I need to do, simple, while rows, what we are doing, we are incrementing every time, right? So row is less than m, and columns we are decrementing every time, so column is greater than equal to 0, right? So this is nothing but my while loop. So in while loop I am giving these two things. Now here, if grid of row and column value, okay, if this value is less than equal to 0, right, negative value, then I have to count all the values which are below this, right? So count is equal to count plus the total number of rows that I have, m minus the current row that I am in as of now. So I'm updating this, and then column I'm decrementing, right? Maybe in previous column also we have some negative, right? Else if it is a positive, then definitely previous columns will be positive only, right? Then let's move to the next row plus plus. That's it. This is your code. Now let's run it. So see, all the test cases have been accepted, right? Now let's submit it. So see, our solution is accepted, right? That's it. Okay, so continuously we are checking everything, right? Rows and column, right? So I hope that you guys are able to understand today's problem, and if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you. Bye bye.